All right, welcome everyone to the final session of the meeting, and thank everyone for staying. I'm Arthur Hager with the Georgia Department of Public Health Laboratory, and our first speaker is Emily Lisi, and she's going to talk to us on direct-to-consumer genetic testing. Emily?
All right, thank you guys for having me. So I'm a genetic counselor. I work at the Mayo Clinic in the Center for Individualized Medicine. The orange one. So I'm going to talk about what I'm calling the rise and fall and rise again of direct-to-consumer genetic testing. So my disclosures are that I work at the Mayo Clinic. They have a collaboration with a lab called Helix to start a direct-to-consumer genetic testing application, and I'm working on that application, so I might be a little bit biased. So our learning objectives, first of all, I'm going to describe and talk about the direct-to-consumer 1.0 genetic testing efforts and the FDA's efforts to then safeguard the community, resulting in the DTC 2.0 type genetic testing, and then outline Mayo Clinic's approach to direct-to-consumer genetic testing. So to start off with, as you guys I'm sure are aware, there's many different types of genetic testing. So direct-to-consumer genetic testing involves a person usually going online and ordering genetic testing without the aid of a healthcare professional to help interpret the results. So there's many, many labs that are in this diagnostic provider-ordered space. That's historically been where genetic testing has lied. But there are many labs that are now starting to offer this consumer-facing, what we're calling edutainment, so education about genetics as well as entertainment genetic testing. So many labs are starting to enter that space: 23andMe, Ancestry.com, Gene by Gene, and many other labs. So obviously there's not really any genetic tests in the space of provider-ordered edutainment, although that might change. And 23andMe has actually kind of entered more into the diagnostic space with being able to offer more disease risk tests, which I'll talk more about in a minute. So the history of direct-to-consumer genetic testing 1.0. So starting in 2007, many labs got into this space, including 23andMe, Navigenics, and DecodeMe, offering lots of different types of genetic tests, some good and some not as good. And based on some concerns about validity and utility, the Government Accountability Office started looking into these types of tests. So they actually did a study where they took 5 donors and had them take 2 samples. And they sent those 2 samples to 4 different labs. One sample had all accurate information about that donor, and the other sample had some false information, like different gender, different race, that type of information. So what they found is that the results were all over the board. So one donor had contradictory results for 11 diseases, another one 9, another one 12, 10, and 9. So the results were all over the place. For example, this male who was 48 years old had a risk of prostate cancer that was average, average, below average, and above average, depending on what lab he sent it to. The same person had the risk of hypertension that was average, below average, and above average. Not consistent. So they were concerned about that. In follow-up, they talked to some of these labs and some of the marketing people, and they felt that the information that they were given was very misleading, that they were given promises that weren't followed through on. So after that, the FDA got involved and became concerned about these tests. So they sent a letter to 23andMe, to the CEO, and said, you know what, we really think that this is a medical device because you're offering diagnostic test information with your 23andMe personal genome service. You have never sent us a pre-market approval, and you've never submitted information on the analytical or clinical validity of the tests, so you should take prompt action. Sincerely yours. So another concern that a lot of ethicists and healthcare providers had was that these tests were going to create a lot of anxiety for the consumers because they weren't going to understand them, or they were going to get results that were incorrect. Additionally, they thought they might start taking up additional screenings that weren't necessary based on the results. So the Scripps Translational Institute did a study where they looked at about 3,600 individuals, and they did baseline testing and follow-up testing on anxiety levels, dietary fat intake, exercise behavior, and they found no significant differences in their anxiety, how much fat they eat, how much they exercise, and really they hadn't done any extra screening based on their results. So you can take that as good or bad. These tests didn't really do anything for them. So again, the FDA. Apparently 23andMe did not respond. They flatly ignored the first letter, so they received a warning letter. And again, they said, we think these are medical devices. You haven't submitted an application for these medical devices. You are diagnosing things. So basically, you need to stop. Sincerely yours. So at that point, they were required to stop. So why did DTC 1.0 fail? So we like to think of genetic testing on a continuum, right? There are some genetic tests that are very diagnostic that need to be provided by a provider who understands those results and can help you understand them. And there's other tests that are, again, more edutainment. So your ancestry, whether or not you have white or yellow earwax, that kind of information doesn't necessarily need to be provided by a provider. So you can think of that as vitamins versus prescription drugs. So these early companies positioned the products with the regulatory people as vitamins, but then marketed it to consumers as prescription drugs. Also, they didn't really explain very well what genetics can and cannot tell you about your health risks, so they were fairly misleading about that. Then they argued with the FDA that these tests were really just informational only, and they were laboratory-developed tests, so they really shouldn't be under the jurisdiction of the FDA. But the FDA disagreed, and they did not like it that they were trying to blur these lines. So what are we going to do for DTC 2.0? It's going to happen. How do we do it right? So going back to our timeline here, 23andMe then re-engages the FDA for carrier screening, and they use Bloom syndrome as their model disease and actually got approval to do carrier screening for Bloom syndrome. A company called Helix was also started in 2015, which I'll tell you more about in just a minute, but it was an Illumina startup company that offers cloud genomics. And then in 2017, just a couple of months ago, 23andMe gained approval for disease risk tests. So there's 10 different tests that they'll test for your own risk of a genetic condition, including Parkinson's disease, late onset Alzheimer's disease, and primary dystonia. So this is an example. There are sample reports online of what the reports will look like when you get your results back. So this is an example of someone who has 2 copies of the E4 variant and the ApoE gene, which is associated with late onset Alzheimer's. So they do cover many bases that the FDA requires, including saying you may be at increased risk, but lots of people don't get Alzheimer's who have this variant, talking about the fact that this is really only valid for people with European ancestry. So again, I said I would talk about Helix. So Helix has developed a partnership with several different institutions, including the Mayo Clinic. So what they offer is actually doing the sequencing for an individual, sending them a saliva kit, doing the Exome Plus sequencing, and then storing that data in a cloud-based system. The partners then get that information and do variant testing and then report the information to the consumer. So they're calling this an ecosystem. So why is Mayo Clinic getting in this space to begin with? A lot of people ask me that question. So the purpose of the Center for Individualized Medicine at Mayo is to educate and engage the public, sharing our knowledge of genomic data and implications for our health. So we felt like this was a good way to actually enter that space in an appropriate way. So they actually have a long-term vision for direct-to-consumer genomics, starting with personalized education at the bottom of this pyramid. So that would be the DTC app that we're creating, moving up to supportive genetic services and then medical services. So in this app, we want consumers to learn about genetics and the impact of that on their health. So we offer lots and lots of educational material and are working very hard to help explain the results in a meaningful way. So we're providing insight in addition to data. So we're offering the genetics education, which we're calling Genetics 101, some carrier screening, testing for complex genetic disorders, some pharmacogenomic testing. We're offering a tool where the consumer can draw their own pedigree and then get some information about that. We're offering the Emory B-Risk tool to find people that are increased risk for hereditary breast and ovarian cancer syndromes and referring those people to a genetic counselor. We're offering information about the environmental impact and have a tool for that of complex conditions, some minimal ancestry testing, and then offering the people the ability to participate in research if they want to do that. So the next tier on our pyramid is expanded services. So thinking about possibly testing people for the ACMG panel or complete carrier screening or some more pharmacogenomic testing. And this would involve an e-consult telemedicine with a genetic counselor or another healthcare provider. And then finally, the top of the pyramid. So this is kind of the long-term goal. So for people who need an expert evaluation, so somebody who has an undiagnosed genetic condition or a history that makes us concerned about hereditary breast and ovarian cancer. So they could actually send their saliva sample in, have the sequencing performed, and then see the physician, and then have targeted testing based on their phenotype. So cutting down on that turnaround time significantly and costs associated with the tests. So based on that long-term goal, the Mayo Clinic went to the FDA. So here's some of my colleagues standing outside the FDA. So what does the FDA want to see? What's going to make them happy? First of all, it's all about safety. That shouldn't be a surprise, right? So they're trying to mitigate the risks associated with people getting these kinds of results without a healthcare provider interpreting them. So they want us to proactively engage the FDA. So submit a pre-submission, tell them what we're doing, get feedback from them, and use that feedback to help create a better product. They want us to be transparent about the limitations of genetic testing. So don't mislead our customers. Be clear about the intended use. So what are we doing the test for? Is it for carrier screening? If it's for carrier screening, we really shouldn't be providing a diagnosis of cystic fibrosis if they have 2 variants. We need to provide analytical and clinical validity. So we need to have validity for every single variant that we're testing for. And define risk and benefit to the consumer. Be very straightforward before they buy the product and then in the product, what they're getting themselves into. And then make sure that the consumers understand. So we have to do extensive comprehension testing where the consumer has to get 90% on a test to show that they understand the results. That's proven really, really difficult. So why do consumers purchase direct-to-consumer genetic testing? There have been several papers out there about this. So first of all, they want to obtain health-related information. They want to learn about their genetic risk factors. They have curiosity about technology and genetics. They think it's pretty cool. Some people have pride as early adopters of new technology, so they're the first people to buy an iPhone, they were the first people to get a Mac, and now they want to do direct-to-consumer testing. One paper talked about identity making, so learning about your genomic self and how that might impact who you are and how it might have impacted who you are. And then again, there's this fun factor of knowing this information. So in one paper that was more kind of theoretical and philosophical about why people do direct-to-consumer testing, they talked about this author, Dickinson, who said it's a new model of healthcare directly linked to the private sector and dictated by narcissism and the ideal of personal choice. So fairly narcissistic to want to know about yourself and then post that on Facebook or other types of social media. They actually disagreed with that. They felt that genomic information is personal and social at the same time. It's personal because it's about yourself, but it's social because it actually impacts your family and other people around you. So what do consumers want to see? Again, there have been a few papers out there about this. So consumers in this particular study were most interested in learning about their ancestry and about their traits. Again, kind of that edutainment, right? A lot of people are actually concerned about their disease risk, maybe a little less concerned about carrier status. Perhaps these people were past reproductive age or just weren't worried about their family as much as they were about themselves. We actually did our own study. So we used the Nielsen group and performed a study that was an online quantitative questionnaire. So that we had questions about their knowledge and interest in carrier screening, the risk of common disease and pharmacogenomics. We asked about their interest in direct-to-consumer testing at several different price points. And we asked about who had already had direct-to-consumer testing, why, how did they feel about it. So we had about 1,000 participants. They were between 18 and 69 years of age. They were across ethnicities and socioeconomic levels, so we had a good mix there. So we asked, how interested would you be in having genetic screening to find out if you're at risk of developing a disorder in which genetic plays a role? So most people were actually interested, very interested or somewhat interested, about 65% of the time. About 3% had already had this type of testing. I'm not sure where. We asked what condition, for those people who would be interested, what condition would you be particularly concerned about in terms of your risk for yourself? Most people were concerned about Alzheimer's, followed by diabetes, breast cancer, coronary artery disease. Less people were concerned about severe reaction to anesthetics and eczema. Not surprising. We asked how interested they would be in having genetic testing for medication metabolism, so pharmacogenomics. Again, most people were interested, about 63%, and about 2% had already had this type of testing. And what kinds of medications they would be interested in knowing about. So over-the-counter pain medications, acetaminophen, aspirin, followed by high blood pressure, high cholesterol, antidepressants, with the least interest being in ADHD medications. And then we asked if they had personally ever used an at-home genetic test, and only 6% said yes. Of those who had never had it, would they be interested in having one? And 56% said very interested or somewhat interested. So there is a market out there for this type of testing. So we know what they desire to see, what consumers desire to see, but we feel like they should also demand a few things. So first of all, privacy and security of their genetic data. It needs to be, we have this cloud-based system that we're going to use that's HIPAA compliant, et cetera. So we think that's very important. Also, appropriate consenting, so knowing what they're getting into before they do it, what they're going to get, and especially what they're not going to get. Education, so whether they like it or not, we're trying to educate individuals about genetics and genomics while they're learning information about themselves. And then the availability of professional genetic support. If they have a result that was not anticipated, that needs follow-up, we want to provide that for them, whether it's a visit to the Mayo Clinic or us finding somebody local for them to see. And then we think that valuable, trusted content is really important. Okay, so to show you a few pictures of what our old product looked like, so our prototype has changed significantly, but just an idea of what we're doing here. So we're offering 4 different categories of conditions, so disease risk, carrier screening, pharmacogenomics, and health traits. So we are offering quite a bit of education, including beautiful drawings of mucus in the lungs for cystic fibrosis. And then we're offering personalized results. So this is an example of cystic fibrosis. Again, the view of it has changed significantly, but the content is very similar. So this would be somebody who does not have a variant found, so they're not likely to be a carrier for cystic fibrosis. And then we talk about what they need to know based on that. Somebody who is a carrier but likely does not have the disease. And then somebody, the FDA is not allowing us to say this, somebody who has 2 variants, we're basically saying at this point that they have 2 variants and they need to follow up with their doctor. We also talk about what they can do with the information. So somebody who is found to be a carrier, we're offering discussion guides for them to talk to their healthcare provider, to their partner, and to their family so that they better understand how to do that. And then for somebody who does have a positive result, they can message a genetic nurse at Mayo and then get escalated to a genetic counselor or other people as appropriate. So how will we know if we got it right? I mentioned the comprehension testing. So we're doing lots and lots of iterative testing and then changing our content based on the results of that testing. At one of the early prototypes said we're testing for 23 variants in cystic fibrosis. you were found to have 2 variants in the CFTR gene. And a lot of people said, great, I only have 2 variants. So we knew we needed to change what the results looked like. So in closing, it takes a village. These are all the people that have been working on this project for the past 2.5 years. I've been working on it for about 1.5 years. These are only the Mayo individuals. There's lots of outside groups, design groups, coding groups, things that are above my pay grade. So I'm supposed to give a plug for the conference that Mayo is having. It's the Individualizing Medicine Conference in Rochester in October. I went to this meeting last year and it was fabulous, very future thinking. And October's not a terrible time to be in Rochester. That's it. Do you guys have any questions? Yep.
So as part of your education, do you talk to them about the implications that this may have for other family members so that they understand that?
Yes. Yeah, so we have lots of diagrams of pedigrees, et cetera. And then, for instance, in our family discussion guide, we talk about the risk to their siblings of being carriers, et cetera. Yeah.
Hi, Emily. I'm Hans Anderson. Thanks for coming. It's a fascinating topic, and I have more questions than we probably have answers for, but if I could ask a few.
Sure.
When you bring a patient who calls in to a genetic nurse and then escalates to a counselor, is there an additional fee associated with that?
Not at this time. No, obviously, if they have a genetic counseling appointment, there would be an additional fee associated with that, but just the contact and being able to talk to somebody on the phone, no. The caveat to that is, particularly with genetic counselors, there's licensure issues depending on what state you live in. So the genetic counselor would not be able to provide any medical advice based on their results, but could help them understand what the results mean, if you understand that subtlety a little bit.
I understand it very well. My wife actually did this for interest's sake, and was charged $250 for the hour that she could talk to the genetic counselor about it. And anyway, so I guess I have a couple other comments, if I may. So one of the things I think is most important to me when I hear you talk about this is that you said there's a market for this. And so I think that's why this happens, and I'm still not quite sure what problem it's solving. And then just lastly, I'd like to call everybody's attention to a JAMA editorial that came out in June 27. JAMA, June 27, if you Google JAMA, direct to consumer with the hyphens, you'll get this editorial. It's very interesting, one-page editorial. You can probably find it online. I think one of the things that editorial brings out is that folks do this testing, they get results, and they bring their results to their primary care doc or their non-genetic specialist. And the editorial suggests that it is dramatically, dramatic's my word, not theirs, that it is increasing the cost of medical care, potentially unnecessary medical care, because the clinicians don't know what to do with this. And then they send the patient to a genetics clinic appointment for their carrier status of MTHFR or some
We're not offering MTHFR carrier screening.
Well, but this is what's going on, and I appreciate you guys taking a really careful approach to this, but this is really important. And there are so too few of us already to do care that if we have to start seeing folks for their traits and interpreting that, that's just so compounding the problem so that the corporation can make money off of the market.
I don't disagree with you, but I do have a response. So I was very reticent to get into this space for obvious reasons. However, I do feel like it's going to happen, and I feel like there needs to be responsible institutions that do it the right way. That's my Mayo hat.
So when you do it, do you give a posterior probability of being a carrier? Obviously, you're not doing full sequencing, so if you do
You mean
X
like
number of
residual risk? Yes.
I'm sorry?
Residual risk, you mean?
Yeah?
Yes. So that's one thing the FDA requires, is for us to give
Because nobody
residual
else
risk.
does that, right?
They
just
do
say-
now. They do now. So
Okay.
23andMe does now because the FDA requires it. 23andMe, I will say their product has improved significantly since they have engaged with the FDA. I'm not promoting them by any means, but it has improved significantly. But there are lots of things that are just special control requirements from the FDA to do that. In response to the statement about increased costs, so I mean, there is a study that has come out that said that isn't the case. Now, whether, chicken and egg here, I don't know. We are trying very hard to provide the education that will help consumers understand what they would need to go to a physician for and what they don't need to go to a physician for. That's one thing that we're working really hard on. I'm a genetic counselor. That is my primary role in this product, to make sure that this is done in the best way it can possibly be done. Mm-hmm.
And I have one last question, and it has to do with the ability of the patient to be sure, because I get asked about this all the time, that if they so designate that their test results will be destroyed after and not used for future research in any way.
Right.
And so often, if you submit blood to a hospital laboratory, they take off the name and they can send it on for future research somewhere else. And so working in psychiatry and neurology, it is a big concern of most of the patients I see.
Yeah, and I think that's a great question. We do have a very specific consent statement where individuals can opt in to research or opt out, and that doesn't in any way affect anything else about their product for them. We are not looking to profit from providing genetic data to outside companies, perhaps that other companies might be doing. The one caveat is that Helix, who is our partner doing the sequencing, one of their platforms is that you get your genetic data sequenced once, and then you can query it multiple times using multiple different products. So in that way, it's being stored. It's being stored for your future use, but it's a good question.
Laura Martin, Tallahassee. I just have a I hope, brief question. You described a process and a system. Am I not tall enough? No doubt. You've described a system in which you have encapsulated the entire process. The patient contacts you, you control where the DNA goes, or blood, and you control the results. So have you interfaced at all with the new system that I have personally come into contact with, where the patient or the client, the business client, sends their sample to someone like Ancestry.com. They offer the opportunity for the patient to download their entire genome onto a thumb drive, and then they upload that to a second company called Prometheus in this particular instance, in which they will then look at the data and create action forms, I guess is the best word I can find. And then they hand it to the patient, and the patient does what they wish. In my case, they came to a cancer genetics program because of the information. And the caveat statement was said that one company always finds this change, and they can't validate how likely it is to be true. And I just wondered if you have interfaced, or the Mayo Clinic has interfaced with this particular system process, and how are people feeling about this data being promulgated through our system. I think it relates to what Hans is saying as well, creates a variety of issues, not just cost or manpower, but all of those that you've just described that the FDA say are required hoops to achieve, but clearly have not because of the truncated process. So I'm just interested in how you look at that.
Yeah, so our product would not provide the raw data to consumers based on the fact that our goal is for people to really understand their results, and we feel like if you provide the raw data, it's not giving them any meaningful information. We feel very strongly about not testing, for instance, for BRCA 1 and 2, because that's not something you should receive through direct-to-consumer genetic testing. You should see a genetic
Are
counselor.
people showing up to your Mayo Clinic, your personalized system, whether it's in Jacksonville or Rochester, with this raw data result, asking your counselors to provide insight or management and surveillance? They are.
I can't personally answer that question because I'm not in their clinic, but my guess is that yes, that does occur. I would say that's why we do need responsible institutions doing this type of testing, so that that doesn't happen.
It doesn't seem to be any FDA oversight for these truncated, Venn diagram, overlapping. And
My guess is that will change. So it took a while for the FDA to recognize the problems with DTC to begin with. So my guess is that'll change, hopefully.
Thank you very much.